Okay, so let's solve another example on Green's theorem. This time, let's take a triangle. So remember the first example, we had a circle. Now let's take this curve. So this is my triangle, this way. Let's say this point is 1, 1. This is 1, 0. So that, for example, f equals, regardless, whatever the function is, that doesn't change anything. So it's x squared plus y, then 2x. And let's find the integral over c f dot dr. Before solving, I just want to remind you of some stuff usually. So how do we think about these questions? The first thing, is f conservative? Remember, this is so important because if the function is conservative, the integral is 0. So quickly, we differentiate with respect to y, x squared plus y, that's 1. We differentiate with respect to x, the second coordinate, 2x, that's 2. They're not equal, so no, it's not conservative. So this means, although we have a closed curve, the integral is 0. So what's then? If the function is not conservative, what else can we do? Then we can do it using parameterization, yes. And remember, this is always our rescue. So all the time, in the worst case scenario, we go back to parameterization. But in this example, we have 3 pieces, 3 line segments. So if we want to do it using parameterization, we have to do a parameterization for this, then a parameterization for this line segment, another one for this line segment. We do all the calculations, we add, which is really tough. It takes some time. This is the credit given to Green's theorem. So what does Green's theorem say? So Green's theorem says, don't do any of this and do the integral using a double integral. This is the advantage, the big advantage of Green's theorem. So as a double integral, first of all, we need a region to integrate on. What is this region? I'm going to draw it here. So we are integrating over this triangle, the solid triangle. And for this one, we don't have any direction. What is the integrand? The integrand, just to remind you, it's the derivative of the second coordinate with respect to x minus the first coordinate with respect to y dA. We are so lucky that, so this is my triangle. This minus this is just 2 minus 1, which is double integral of 1, and this is what? This is just the area of the triangle. And what is the area in this example? It's just half. So if you make a little comparison between these computations on the left and those computations on the right, imagine we had a parameterization for each of these line segments. That would take us at least 15 minutes. Now we're done.